So far we've been working with series, one-dimensional labeled data. But in real life, we rarely work with just one column of information. We have tables, rows, and columns, and that's exactly what a data frame is for. Let's go ahead and create a simple data frame. Here I have a data dictionary where my values or my keys are ID, names, and scores. I'm gonna convert that into a pandas data frame by just calling pd.dataframe, where the data is going to be this data variable here. If I go ahead and print that out, here we go. Looks exactly like a spreadsheet. We have our columns, ID, names, and scores, and we have indices for our rows right here. So your data frame is basically a data dictionary where your keys here are your columns and the values are the list of values for that column. Now these default numeric indices are fine, but in real life we usually have our own identifier that we want to use, whether that is a student ID, a product ID, something that uniquely identifies that row that would be more natural for us to use rather than positional indices. So here I can actually change my index for my data frame by doing data frame set index, and the index that I want to use here is basically the column ID. If I go ahead and run this, you'll see that it removed the numerical indices and used my ID as my identifier for the rows now. Now here's the thing, if I actually do df again just to see what the values are, everything goes back to normal. The reason is that when you call set index, you still need to capture whatever comes back out of this function into the variable. So whatever comes back from df.setIndexID will need to be stored again into this original variable. Or another way you could do this is by calling the inPlace property and setting that to true. Now if I run this, nothing changes here, but if I call my df one more time, here we go, we get it persisted on the original data frame. But also notice how this is no longer part of the data frame itself, it's just the row index. Now if I wanted to revert that, I wanted to bring that back into my data frame, I would do something like this, data frame dot reset index. First, I'm gonna set the drop to false, because what it would do when I call reset index is that it will drop this value altogether and basically will only keep the names and scores and will set the indexes to be the numerical indices of 0 through however many rows you have. But when I do drop false, that will ensure that this does not get lost, it just gets added back into the data frame itself. And the second thing is to also make sure that we're setting this in place so it stores it into the original data frame right away. If I run that, and let's see what data frame looks like. Here we go, our ID becomes a column again and our indices becomes those default numerical indices. Now if you happen to want to have both, you want the index to be both a column and a row index, we could do something like this when we created our data frame. So I'll do data frame 2 equal, let me move this up, pd.dataframe, where the data is going to be data, the index is going to be the data at this position or at this column. And if I print out df2, here we go, I get that column as both my indices as well as my IDs. So between set index and reset index, you have full control over how you want your labeled data to be displayed. And in real data sets, you'll find yourself needing to switch back and forth because sometimes you just want the indexes to give you easy access into the data that you're looking for. And in other cases, you just want to merge them all into one data frame so you can prepare them for export or whatever else you need to do. Next, we'll see how we can use those indices to access our rows and columns using the iLock and the lock functions.